Hello everyone, and welcome to ILAN Technologies presentation on DrayTek IPv6 solutions. My name is Roy Pineda, and I am the Technical Manager at ILAN Technology. And today, together with Paul Ang, who is our Network Engineer at ILAN Technology, we'll give you an overview of IPv6 on DrayTek Routers. It'll include some theory on IPv6, as well as some examples on how it is used in DrayTek Routers. So I'll now pass you on to Paul, who will tell you more about DrayTek IPv6 solutions.
Thank you, Roy. My name is Paul Ang. As Roy has mentioned, today's webinar will be DrayTek IPv6 solutions. In today's agenda, the topics that we are going to look at are IPv6 Basics, what is IPv6, IPv6 Addressing, IPv6 features and advantages, DrayTek IPv6 transition strategies, dual stack to handle both IPv4 and IPv6 networks, tunnel mode to get IPv6 addresses, and DrayTek IPv6 WAN connection type, native IPv6, tunneling IPv6, DrayTek IPv6 LAN, and DrayTek's other IPv6 features. Now we will look at IPv6 Basics. What is IPv6? Internet Protocol version 6 is an addressing protocol that will meet the future demand for IP addresses. This is the solution for IPv4's limited and depleting IP addresses. The length of IPv6 address is 128 bits and is 2 to the 128 or approximately 3.4 times 10 to the 38 possible addresses, while IPv4 addresses is 32 bits. IPv6 is composed of hexadecimal numbers, which starts from numbers 0 to 9 and 10 to 15 were replaced with letters A to F. Computers and routers only understands binary numbers. To convert hex to binary, we will represent the 4 binary bits as 8421, as you can see from the slide. Then simply bring down 8 and 2 and then add those numbers, and the sum is 10 in decimal and A in hexadecimal. Here we can see the IPv6 terminologies used to describe addresses. Global unicast is IPv6 addresses that works like a public IPv4 addresses. Unique local is IPv6 addresses that works like a private IPv4 addresses. And link local is IPv6 addresses that is valid only for communications within network segment. Like link local, IPv6 work like a APIPA or automatic private IP address from Microsoft Windows, which normally starts from 169.254.224 or .212. Each addresses type always started with a first hex digit like 2 or 3 for global unicast, FD for unique local, and FF for multicast. Also, the FE80 for link local. There are different parts or groups of an IPv6 address, just like IPv4. The first group is global routing prefix, which is the first 3 groupings of numbers or first 48 bits. It is also called network ID, used for routing. Subnet ID is the 4th grouping of numbers, the 49th through 64th bits. It is the number that identifies the subnet within a site. Functions like a subnet field of an IPv4 address. The last part is the interface ID. It is the last 64 bits, which act like an IPv4 host field. IPv6 addresses uses 4 times more bits compared to IPv4. That makes it longer and difficult to document. That is why there are guidelines on how to shorten IPv6 address. Here are the guidelines. Leading zeros in a quartet are optional. For example, the quartet is 08A5 shortened to 8A5, and the quartet zeros shortened to 0. Successive quartets of 0 can be replaced as two colons, but this method can only be used once in an address. For example, in the slide, you can see 8 zeros highlighted in red. These 8 zeros can be replaced with two colons. There is also a guideline to expand IPv6 back. In each quartet, add the leading zeros as needed until the quartet has 4 hex digits. If double colon exists, count all the quartets and replace the two colons with multiple quartets of zeros so that the total is 8 quartets. Here you can see the network ranges for expanded, abbreviated, prefix lengths and device range in subnetwork of IPv6. In expanded notation, all zeros still exist, while the abbreviation notation, the leading zeros were replaced with two colons. In prefix length, we simply add the /64, which represents the global routing prefix, and the subnet ID, and then lastly, the device range in subnetwork. Now we will look into IPv6 features and advantages. IPv6 features and advantages are global reachability, simplified header, eliminate the need to use NAT, auto-configuration, and no broadcast. In IPv6, every device has a unique IP address and can directly reach with each other in the internet. IPv6 header has been simplified to 8 fields. As you can see on the slide under the legend, 3 field names are kept from IPv6 to IPv4, namely version, source address, and destination address. 7 fields are not kept and 4 fields were renamed and repositioned, and 1 new field name flow label. IPv6 addresses do not need NAT anymore because the addresses are more than enough to supply the demand for each device that connects to the internet. There are 2 types of auto-configuration. The stateful auto-configuration is when a computer obtains IP addresses from a DHCP version 6 server, while stateless auto-configuration, the computer will assign its own IP address. In IPv6 stateful auto-configuration setup, the stateful DHCP v6 assigns the following to the host. Unicast address, this is the IP address of the host. Prefix length, also known as the subnet mask. DNS servers IP addresses. And while the default gateway IP addresses is provided by the router itself by using NDP, or what we call it, Neighbor Discovery Protocol. As we can see on the slide, the only difference between IPv4 and IPv6 DHCP is that IPv4 provides all those information including the default router IP address. In a stateless auto-configuration setup, the router will use NDP to advertise the following. Prefix, this is also known as a network IP address. Prefix length, also known as a subnet mask. Default router, this is the default gateway IP address or the router's IP address. So before the host or the client can create its own unicast IP address, the host will send a request to the router known as RS, router solicitation, and then the router will reply with RA, router advertisement, with all of the information under NDP. After the host or client receive all of the information from the router, the host will now create its own unicast address based on its MAC address, prefix, and prefix length. And lastly, the DNS server's IP addresses is provided by the stateless DHCP version 6, which can also be the router, because routers today have an option to perform as DHCP v6 server. IPv6 no longer uses broadcast. Instead, it only uses unicast, multicast, and anycast address. It no longer affects the performance of the hosts or computers in the network because the NIC or the network interface card will be interrupted by the CPU to process broadcast. So all computers in the network must process broadcast even if the message is not intended for them. Now we will look at IPv6 transition strategies. Dual stacking is an integration method in which a router has implementation and connectivity to both an IPv4 and IPv6 network. This is the recommended option and involves running IPv4 and IPv6 at the same time. DrayTek provides an additional memory stock to handle the IPv6 related traffic and services. This dual stack functionality enables DrayTek routers to handle both IPv4 and IPv6 at the same time. The online status page shows both the IPv4 and IPv6 network status. For example is IPv6 PPP, which requires a dual stack router to work because IPv4 WAN setting should be using PPPoE client. So the RSP can provide an IPv6 address. To use IPv6 PPP, you just need to choose the connection type to PPP. No other settings is required from the router. Tunneling is an integration method in which an IPv6 packet is encapsulated within another protocol such as IPv4. This means adding an IPv4 header to the IPv6 packet. It includes a 20-byte IPv4 header with no options to the IPv6 packet, and it also requires dual stack routers. An example of tunneling IPv6 is 6-in-4. 6-in-4 is a transition mechanism for migrating IPv4 to IPv6. It also uses tunnels to encapsulate IPv6 packets over IPv4. In this method, the IPv6 connectivity is provided by a tunnel broker on the IPv4 internet through a tunnel configured manually. To use 6-in-4 static tunnel, you need to sign up for a tunnel broker service and get an IPv6 address and routed IPv6 prefixes first. Then configure the router as follows. Set connection type to 6-in-4 static tunnel. Enter the tunnel server's IPv4 address in a remote endpoint IPv4 address. Enter the router's IPv6 address in 6-in-4 IPv6 address, and enter the routed IPv6 prefix in LAN routed prefix. All of the information that I mentioned will be provided by your tunnel broker after you sign up for this service. Now we will look at DrayTek IPv6 WAN connection type. DrayTek support two types of IPv6 WAN connection, tunneling IPv6 and native IPv6. Native IPv6 is normally provided by your RSP as additional service. DrayTek supported PPP, static IPv6, and DHCP v6 for native IPv6, just like IPv4 which uses PPPoE, DHCP, and static IP. This will require dual stack routers. If native IPv6 is not possible to get from your RSP, then we can use tunneling IPv6. Tunneling IPv6 requires us to sign up for a tunnel broker. The tunnel broker will encapsulate the IPv6 packet by adding an IPv4 header to the IPv6 packet, or by mapping an IPv6 address to an IPv4 address to an IPv6 address. Now we will look at IPv6 LAN. Here we can see that there is an option for assigning IPv6 for LAN clients. To assign IPv6 address, we will go to LAN, General Setup, and select IPv6. We will also need to select the WAN interface that has IPv6 service available as well as the HTTP-v6 service. Finally, we will look into other features. IPv6 addresses are also supported by firewall filters. As you can see on the slide, we can select IPv6 groups and objects for filtering. We can also implement QoS based on IPv6 addresses. And now we will show you a video which demonstrates how to configure IPv6 on a DrayTek WAN interface using PPP mode.
Welcome to DrayTek Australia and New Zealand. In this video, we are going to configure IPv6 on the Vigor router using PPP mode. In our setup, we are using a Vigor 2860 and our RSP is Internode. First step is to enable IPv6 feature via RSP. For Internode, we will need to access and log into their website to activate the IPv6 service. The second step is to enable IPv4 internet connection. So Internode uses PPPoE for authentication. From the router admin page, go to WAN, Internet Access, and select WAN 1 Details page. Select Enable and make sure that VPI is 8 and VCI is 35. Enter the username and password provided by Internode and then click OK to save your settings. The router will need to restart to apply those changes to take effect. The third step is to verify the IPv4 internet connection. To check the IPv4 is working, go to Online Status, Physical Connection, and look for WAN 1 status. As you can see under WAN 1 status, the uptime is 24 seconds, so IPv4 internet connection is now working. The fourth step is to configure IPv6 PPP mode. Go to WAN, Internet Access, and select WAN 1 IPv6. Under IPv6, select the connection type as PPP and then click OK to save your settings. The router again needs to restart to apply those changes to take effect. To check if the router has assigned IPv6 address, go to Online Status, Physical Connection, and select the IPv6 tab. As we can see, IPv6 is up in about 11 seconds. The last step is to test IPv6 connectivity to the internet. To test it, we will go to Diagnostic, Ping Diagnosis, select IPv6, and enter IPv6 address as ipv6.google.com and then click Run to execute the ping. Thank you for watching the video. For more information, please visit our website www.draytek.com.au or you may email us at sales@draytek.com.au.
Alright. Okay, hope you enjoyed the video, and if you wish to watch again, just visit the link shown here on this slide. So we have given you the overview of IPv6 on DrayTek routers, and this includes the IPv6 Basics. What is IPv6? IPv6 Addressing, IPv6 features and advantages, and IPv6 transition strategies, which includes dual stack to handle both IPv4 and IPv6 networks, tunnel mode to get IPv6 addresses, and DrayTek IPv6 WAN connection type, which is native IPv6 and tunneling IPv6, and DrayTek IPv6 LAN and other features.
All right, thank you, Paul. Yeah, what I'll do is at the end of the webinar, I'll email everyone a link to the PowerPoint presentation. So thanks everyone for taking part in our presentation today, and we hope to catch up with you in our next webinar in the coming weeks. Probably be another 2-3 weeks, we'll have another webinar. So thank you everybody, and bye for now.